I'm Francis. I'm going to be talking about how I'd like to improve Canadian modeling estimations of soil organic carbon sequestration in our manure-amended croplands. A little bit about myself. My background is in soil science. That's what I did my bachelor in. Now I'm doing my master's at the University of Guelph, and I'm focusing on soil carbon modeling. And that's a great subject for me because obviously I'm fascinated by soil science, but I've also been playing around with computers for basically my entire life, since as far as I can remember. And this picture attests also to as far back as I can't remember even. Now in Canada, the way we do soil modeling is we use what's called the century model, and I'll talk more about how that works and what that is, in order to estimate or predict soil organic carbon sequestration from our land use and land use change sector. These predictions are then put into the National Inventory Report that aggregates Canada's greenhouse gas values across the country, and then those are all sent to the IPCC for global greenhouse gas reporting. So the century model is what's called a soil biogeochemical model. And all this means is there's a bunch of different equations that all work in tandem in order to predict certain qualities and quantities of the soil and crop system that you're interested in. So there are a bunch of different, what are called submodules, that are just full of different equations that interact with each other. And these are things like soil, water, nutrient dynamics, plant growth, and what's most critical for our sequestration estimation is the soil carbon submodule. So in Canada, we use this model in order to estimate carbon sequestration under things like converting grassland to cropland, fields that employ summer fallow, fields that use reduced tillage, fields that change to perennial crops. But one thing we don't take into account are fields that use manure amendment or organic residues. It's too bad because the carbon sequestration that could be born from this is estimated to be about equivalent to the carbon sequestration from all the other land use changes that I just mentioned. The only reason we don't account for this right now is because when the modeling was set up, there was a lack of data with regards to manure amendment. But now that more long-term manure amendment trials are opening up and the data is becoming available, now might be a good time to actually include this into our models. So maybe the obvious research question here is, how can soil carbon sequestration from manure be taken into account for Canada's national greenhouse gas inventory? That's not really the research question I started out with, though. My question was just, how do we do modeling? What are models and how do they work? And in order to do that, in order to figure that out, I spent about 12 months working with the century model. Not full time, but it took a while to actually get my first model up and running. And here's what I've come up with so far. This is one site, the Ottawa Central Experimental Farms long-term manure amendment site, where they have 6 different treatments: manure nitrogen, semi-composted manure, mineral nitrogen, semi-composted manure, and stockpiled manure. And these are all applied at 2 different rates, a high and a low rate. The dots, the points, are measured data straight from the field, and the lines are the simulated data from my century model. So the first thing that should stand out to you is how much the lines don't really match up with the points. And that's because I didn't do a great job on this model. It's just not great. And I don't think that's Century's fault. I think that is my fault. But I'm here to say that I think Century does some things that make it hard for me to make this model in the first place. It's very complicated, the century model. There's a lot of moving parts. I think what's most important is the fact that plant growth really dictates the speed of carbon retention in the soil, or plant growth really has a huge impact on how much carbon sequestration there is, which means I'm responsible for modeling plant growth, which is something I'm not qualified for at all. I don't know the first thing about how plants grow, but using the century model, I need to know, or I at least need to pretend to know. I was explaining this kind of issue I was having to some government researchers last week, and they thankfully kind of agreed and said they were researching another model that was based on the Sentry model that they called the IPCC Tier 2 model. And what this is what's called a steady state solution of the Sentry model. It just means they've taken all of the equations out of the soil carbon section of the Sentry model and stripped everything else away. So nothing else in the Sentry model matters except for the soil carbon, according to this model. It's a little bit more complicated than that. This is what it actually looks like, but it is definitely a lot less complicated than the Sentry model. And critically, you don't have to model plant growth. Just to give you some perspective here, there's over hundreds of parameters in Sentry that you have control over, that I have control over, even more terrifying. Whereas in the IPCC Tier 2 model, there's only 27 parameters. That should give you an idea of the scale of complexity. So I immediately got to work on trying to use this new model, see how it compared. And the red line is what I came up with. Yeah, it's even worse than what I had before, generally. The mineral nitrogen sites, okay, those might be a bit better, but the manure is looking pretty bad with this. And I think the reason for this has to do with how it handles carbon input. Because the way Sentry handles carbon input here on the left is you can have an infinite amount of different carbon sources, and they each have their own nitrogen and lignin contents. That's very similar to how this IPCC Tier 2 model works. Of course, it's based on Sentry, so it should be similar. Except the difference is there's only one column in the IPCC Tier 2 model to designate the quantity of carbon input, which means that all carbon is treated equally, whether it's manure or crop residue. They all have the same percent lignin and percent nitrogen, which we know, in fact, is not true. Carbon from crop residue is very different from carbon, or not carbon, but the organic matter itself from crop residue is very different from the manure organic matter. So one way we can get over this is by using weighted means. If we are able to separate out the amount of carbon and manure, the amount of residue and manure carbon, we can calculate weighted means of our lignin and nitrogen contents, put it back into the original spreadsheet with just total carbon input, but with our weighted means. And what we get looks something like this blue line. Okay, a little bit better. It's still not perfect. So now I had to pull out the big guns. I wanted to modify the model. Here's the regular models on the left and the modified versions on the right. It's a very small modification, but I just wanted to add two different types of carbon input. There's residue carbon input and manure carbon input, and they have their own coefficients for how they're proportioned into the different soil carbon pools. So when I did this modification and made the new model, what I got was, oh, okay, yeah, it's the exact same as doing weighted means. I looked at the math, and yeah, it makes sense. The way these equations work, yeah, it'll be the exact same. So if I want to make a modification like that, it's got to be a little bit more in depth. One thing that I could look at, one thing that might improve the model a lot, is changing how I think about manure carbon input quantity. Quantity of carbon is definitely the biggest contributor to carbon sequestration. And maybe there's some easily accessible data source that I'm not thinking of. Maybe there's some remote sensing way to estimate manure carbon input. I don't know. I'm going to have to think about that. Another thing is maybe manure quality will affect soil carbon retention in a substantial way. And if it does, can this be parameterized into a model?